2.7, this is a preview of transformations. You have to understand very basic movements given some changes to a basic function. So here are some examples. For example, the parent function, parent as in your parent. The parent function is this, f of x. F of x equals x. That's the function you're starting with, and that's what is graphed here on the screen. That's the diagonal line. But if you do something to that function, such as put a -2 behind it, then you must understand what that does to the graph. And when you put a -2 behind that and come up with x minus 2 for a new function g of x, what that does is create a vertical translation down 2. So notice what's happened. The graph was here. That's f of x. When I put a -2 behind it, it knocks it down 2 places. That's a transformation. Vertical translation 2 units down. Okay, for this one, f of x is still the parent function, but now you have a 2 in front of the x. Anytime you put a number in front of the x, what's going to happen is either a stretch or a compression. In this case, if you have a whole number, like 2, then that's going to make a vertical stretch. If you know basic slope, then you can use that to figure out how it's going to be moved. So here is the basic graph to start with, and then if I can grab a hold of this, for some reason it's not moving. So it'll move like this. No, it won't move at all. Huh. Well, when I go to move it, nothing happens. So we'll just do it like this. If it's 2x, then you know it's got to have a slope of 2, so it's going to go up like this. So we can just graph a new line. And then down like this. The new line would look like this. And that's not the line that I wanted to draw. So we'll take that one out. And instead of an arrow, we'll put an actual line. There we go. Try to make this close. There we go. So that would be a vertical stretch by a factor of 2. The description of this is a vertical stretch by a factor of 2. That means it's going to stretch it upwards and closer to the y-axis on either end. Now on this one, the parent function is still x, but the new function is negative x. And whenever you put a negative sign in front of the x, that's going to cause a reflection across the x-axis. In other words, whatever point you have here, it's now going to be the same distance away from the x-axis down here. If you have a point here, it'll be the same distance away on the x-axis down there. And if you understand how to graph lines, you can just go through and put a line that goes in the opposite direction. Of course, it won't be a squiggly one like that. We'll take that one out and put in an actual line. There we go. And we'll see if we can get this to go where we want it. That would be the new function g of negative x. And notice that whatever you have here is the same distance away on the other side. It's just a reflection across the x-axis. Now this one is a negative 5x. The parent function is x. And now you've put a negative sign in front of it and a 5. We've done both of these already. What happens when you put a whole number, other than 1, in front of the x? What was the description that we had for that? A vertical stretch by a factor of what in this case? 5. What happens when you put a negative sign? It reflects across the x-axis. So it would be a reflection across the x-axis and a vertical stretch by a factor of 5. And we can draw this one out. It still has a y-intercept of 0. So you start there and you go down 5 and over 1, down 5 and over 1. So we'll go back and then up. And of course there's a dot there. Let's see what we can do with this. Almost got it the first time. That would be the new graph. That would be the transformation. A vertical stretch by a factor of 5 and a reflection across the x-axis. Now you have parentheses around it. And when you have parentheses around the x and you put a number in there, in this case the quantity of x minus 4, this can be a little tricky because if you think since it's minus 4, you're going to go what direction? Yeah, that's the first thing you think of is down, but the parentheses mean that it's going to be a left or right movement. So that's the first thing that's odd about it. It's not an up or down issue, it's a left or right when you have parentheses around it, when it becomes a quantity. Now, knowing that you have to go left or right, where do you think this one is going to go? It goes right. So there's two things that are different about this. So instead of going to the left 4, I'm going to go to the right 4. I'm going to try to move this line again. Hey, this one actually works. So if I move this to the right 4, you're going to end up with a translation like this. It was back here. We're going to go to the right 4. And that's a horizontal translation 4 units to the right. A horizontal translation 4 units to the right. So the last one here is kind of a combination of everything that's been done. You have a parent function of x again, but this time we have a negative 2 in front of the x. What does the negative 2 mean? It's a reflection across what axis? The x, and it's what? What does the 2 do? The 2 doesn't move it down or up. Vertical stretch by a factor of 2. What does the minus 1 do? Moves it down another unit, right. So if you look at this, the negative 1 or the minus 1 goes there. So there's your movement down 1. And then the slope of negative 2, down 2 over 1, gives you the new placement of that line. And let's see if we can draw this somewhat close and move it into place. Oh, that's not really good, but I can't change it. Well, I guess I could. I can take it out and redraw it. There's nothing wrong with that. Oh, I need to be on this side of it. There we go. So there would be your new line. That is a movement down, a vertical translation of 1 unit down, a reflection across the x-axis, and a vertical stretch by a factor of 2. Those are all 3 things you could use to describe that. For this first problem, you're adding a 2. So that's a vertical translation 2 units up. How do I describe putting a 3x in front of it? What is that? Vertical stretch by a factor of 3. What if I put a negative sign in front of the x? What happens? A reflection across x-axis, right. What if I put a negative 6 in front of it? What all is happening there? A vertical stretch, that's right, vertical stretch by a factor of what? 6, and reflection across the x-axis, right. What happens when I have a quantity of x minus 5? What's happening there? Yeah, horizontal translation. Yeah, 5 units. 5 units to the right. And for number 6, look at all the stuff I have in here. There's 3 different things going on. Somebody give me one of them. That's right, there's a reflection across the x-axis. What's the other one? Vertical stretch, right. By what? By a factor of 3. And what else is going on?
Yeah, like a vertical translation, like 2 units up.
A vertical translation 2 units up, right. Your parent function in this case is x squared. So x squared looks like that on the screen. But now we are doing x squared plus 3. So what do you think is happening when I put a plus 3 behind the x squared?
Moving the whole thing up 3.
A vertical translation up 3 units. Let's see if this thing will move. It does. So we've moved it up 3. Another thing I might be able to do is copy and paste it. Oh, it pastes. It also makes it way too big. I've just pasted that thing 3 times, and it made it larger each time, so we'll just slide those off. So yeah, so we'll just move the same one up 3 spots. So here's the parent function x squared, and then the new one is a negative x squared. So what is happening to this? It's what happens when you put a negative sign in front of the x? A reflection across what? The x-axis. Okay. So let's move this, and let's see if we can turn it. Yes, it will actually turn. So we put it upside down like that. And this graph is going to be approximate. The main purpose of this is just to explain what's happening. So it just goes upside down, a reflection across the x-axis. So now in this case we have x squared, and the new function is the quantity of 6x squared. What do you think is going to happen in this case? You can use your graphing calculator if you want to see what's happening.
How do you use your calculator?
Type it in. Like what you see on the screen, type it in to Y1 and hit graph. Your window should already be in the right spot. What happened before? What direction were we going when we had a quantity around our item? Was it up and down, or was it left and right? When we had a quantity around something in the examples we did before.
It was left and right.
It was left and right. In this case, here is what is different. This is a horizontal issue, but it's a horizontal compression by a factor of 1/6. When I compress something, what happens to it?
It'll go in.
It'll go in, right. So this is a horizontal compression this way, and I don't think I can do this justice with the tools on the iPad, so I'll do it like this. That would be a compression. It gets skinnier than what it was before, and it's by a factor of 1/6. So whatever the coefficient is, you convert that to a fraction. In other words, find the reciprocal. It's a horizontal compression by a factor of 1/6. So what happens here with this one, 2x squared minus 6? What does the minus 6 do? It does what?
Reflex.
Not reflects.
Down 6.
Translates where?
Down 6.
Down 6. So we go down to here. And then what happens with that 2?
Vertical circles.
So this one would go inward, like, and remember these continue on forever, but I can't stretch this one out with the tool on the iPad. So 2x squared minus 6 is going to compress it, and then you're going to have a vertical translation of 6 units down. You have a quantity around this, the quantity squared of x minus 2. When we do a quantity, is it up or down or left and right? Left and right. And is it going to go back 2 or to the right 2? To the left? To the right, yes. So it would go 2 units to the right. And you can put that one also into your graphing calculator. And just type it in as the quantity squared of x minus 2. And then hit graph. And it's exactly what we have on the screen.